Okay, so amortized loan with a fixed payment. This again is your car loan or your mortgage payment. So each payment covers interest expense plus reduces principal. Um, a good example here on your, most people uh, take out 30-year mortgages, which I highly recommend. I just recommend paying them off sooner if possible, because you, even at really low interest rates, you end up paying a considerable amount of money in interest. But anyway, so 4-year loan with annual payments, the interest rate is 8%. So on your calculator, we'll go over and do this on a calculator. Um, this is assuming you use that clear time value of money function that I don't use. But anyway, so that 4N, uh, 8 IY, so our rate IY, and then the loan amount is $5,000. That's our PV. The other thing I would do, if I would do the don't know why those icons aren't live, but I would enter payment future value equals 0. That just tells you what the that you're paying the loan off after 4 years. So, but in the compute payment be $1,509.60. Let's go do that. So that's 4N8IY 5,000 present value. That's a positive because you're receiving that money, and then 0 future value, and then compute payment, and we get the 1,500 and let's see, there we go, $1,509.60, just like on the slides. So what's a firm worth? Conceptually, a firm should be worth the present value of all the firm's future cash flows. That, if you recall, in Finance 3301 and investments, you would have calculated the constant growth model and the non-constant growth models. Those are attempting to present value the future cash flows of a firm in the form of dividends. The tricky part of doing this is determining the size and timing and risk of these cash flows. That's that's the art of valuing firms. That's why when we do value firms, we typically would use some sort of sensitivity analysis. That's the end of this chapter with a quick quiz here. The future value of a single cash flow. I'll write out the formula here. Future value is equal to the present value multiplied by 1 plus the rate of return to the t power, t being the number of periods. The present value of a series of cash flows. Didn't show this in the book, but we showed the present value. But basically, all we have to do to calculate we actually did present value is the cash flow multiplied by 1 minus 1 divided by 1 plus r to the n, or t, I'm used to using n, but then we divide cash flow by r. So this is the present value of a series of cash flow, the present value of an annuity. We could reverse this and divide instead of dividing the cash flow by this, we could divide the present value by this and calculate the payment. Net present value of an investment is just minus the costs plus PV of cash flows. EAR is effective annual rate, and it is EAR is equal to 1 plus R divided by the number of compounding periods to the power of the number of compounding periods minus 1. We did 12%. The 12% monthly. Let's do 1.1 divided, so 12% monthly. So that would be 1.01 to the 12th power minus 1. I believe that is 12.1268 or 12.68%. Okay. All right. So last one, if I can. So perpetuity is an income stream that continues on forever at the same amount, does not change. An annuity is similar, except for it has a fixed maturity. So it's a series of payments with a fixed maturity date. So that is all we have for Chapter 4.